We finally have new data on the exoplanet K2-18b. This has been one of the most exciting discoveries in the last decade, because it is a world that could contain clues about the existence of life beyond Earth. This exoplanet, located in the habitable zone of its star, has captured the attention of the scientific community and the general public, due to its intriguing atmospheric characteristics. This has led us to imagine that K2-18b is the first world where we have detected life outside of Earth. It has been speculated in many media that it contains a large ocean full of living beings. And not only that, but there are artificial lights, and that information has been hidden from the public. It is true that something intriguing is happening with this planet, and that certain information is being hidden. But there is a reason for all of that. Is there life on K2-18b? Today I will tell you the great truth of the latest scientific studies found by James Webb about this interesting exoplanet, and that most of it has not been disclosed to the public. What you are going to discover today is very exciting for us, because it can mark a before and after in the discoveries of exoplanets. To understand this, you must know all the studies that exist on K2-18b. This exoplanet was discovered in 2015 with data from the Kepler Space Telescope, and it caught the attention because it is located in the habitable zone. The habitable zone is the ideal region where liquid water can exist, with temperatures between 0 and 100 degrees Celsius. It means that if it were a little closer to its star, the water would evaporate, and if it were further away, it would freeze. So when you see that someone calls a planet habitable, it is precisely for that reason, because it is in the ideal zone, also called Goldilocks. In this case, the exoplanet is located 21.38 million kilometers from the red dwarf, much closer than Mercury is to the Sun, but as it is a much colder star, the habitable zone is also closer, and it is likely to be tidally locked. That is, it always faces its star the same way. The star K2-18 is a red dwarf and is located about 124 light-years from Earth. It is almost half the mass and radius of the Sun, with a temperature of about 3,500 Kelvin and an age of about 3,000 million years, meaning it is younger than our Sun. At the moment, we only know of two planets orbiting this system, K2-18b and K2-18c. The one we are interested in this study will be K2-18b. We cannot see the planet, but we can see the darkening produced by the star as the planet passes in front of it. This is how we know the planet's radius, mass, and orbital duration by studying the behavior of its star and the information packets that reach us when its star illuminates its atmosphere. We know for certain that K2-18b has 8.6 times the mass of Earth and 2.6 times the diameter. If we combine the planet's mass with its size, we obtain its density, and we know that this exoplanet has a density less than half that of Earth, meaning that it is not a rocky planet, but it is at the limit of what a planet covered by a large ocean or a mini Neptune can be. Hubble's first observations. In 2019, things got interesting. The Hubble Space Telescope aimed at this planet to see what it was made of and was surprised to find water molecules. Specifically, it was a signature consistent with water vapor in the atmosphere of K2-18b, catapulting the planet into fame as a possible Earth analog. Although the discovery of water was exciting, Hubble's limited capabilities left many questions unanswered, which is where the James Webb Space Telescope comes in, designed to observe much longer infrared wavelengths than Hubble. First observations with James Webb. The James Webb can delve deeper into the infrared spectrum and offer a more detailed view of planetary atmospheres. In September 2023, the James Webb made its first measurements of K2-18b's atmosphere. Using the NIRIS and NIRCam spectrometers, astronomers found some amounts of methane and carbon dioxide, at least 1% enough to get our attention. However, they found no evidence of water in the exoplanet's upper atmosphere, suggesting that the absorption features previously detected by Hubble could have been caused by methane. In other words, we had detected a false positive. But James Webb discovered something much more exciting. Among the data was dimethyl sulfide. This caught the attention of the media because dimethyl is a molecule that on Earth is only produced through biological processes, mainly by phytoplankton in the oceans, so we already have a lot of interesting data. The habitable zone, carbon dioxide and methane, as well as dimethyl sulfide with a low density. This initially tells us that the planet contains a huge ocean of liquid water. Its atmosphere is mainly hydrogen, quite thick, and that means that this planet produces a greenhouse effect, and that it would have an ocean with higher temperatures than the average of our oceans. The area where it is located is close to the cold habitable zone, meaning that the equilibrium temperature is somewhat lower than our planet. It is around -23 to 27 degrees Celsius. This increase in the greenhouse effect could make it the most habitable exoplanet we have ever detected. And this is the exciting part: methane gas. This gas is often produced by living beings. Detections of natural methane do not last more than 2 or 3 years because solar radiation tends to break down the molecules, so there is something that is continually replenishing it. The big question is that something life? The first preliminary study carried out by James Webb is one of the most interesting models. And it corresponds to an oceanic world, with a vast ocean of liquid water, surrounded by a hydrogen atmosphere. Not only that, but if you add certain types of bacteria such as methanogens that use hydrogen and expel methane, then everything matches. The planet would be full of extremophile microorganisms. To understand dimethyl sulfide, you must understand what type of organisms could exist on planets where this gas is confirmed. Chemosynthetic microbes. With dimethyl sulfide present, there could be microorganisms that use or produce it as part of their metabolism, similar to how some microbes on Earth produce dimethyl sulfide as a byproduct of the decomposition of organic matter. At best, in this preliminary study, there has even been talk of extraterrestrial phytoplankton that could adapt to the light filtered through the atmosphere of the exoplanet, and then dimethyl sulfide would be produced in the process. This is a toxic gas and consists of a pair of methane atoms joined with one of sulfur. It smells like cabbage and is the main molecule produced when cooking cabbage and encourages the formation of sea clouds, although our civilization is more interested in what these bacteria produce than in cooking cabbage. On Earth there are no non-biological sources of dimethyl, so in principle we would have all the ballots for it to be perhaps the first biological signature on another world. So as you can see, the results seem tremendously interesting starting from this simple study. The detection of methane and carbon dioxide are two common compounds in the universe, and it just rounds everything out to get us excited. Preliminary analysis of K2-18b. Here you have a more serious study of the subject. We have considered several scenarios, such as a super-Earth with the first data from Hubble and with James Webb, a habitable ocean world or a mini Neptune. Some researchers believe that these last models are the most reliable. And how do we know if it is an ocean world or a gas giant? There is a gas that can give us the clue: ammonia, and we have not detected any ammonia. Ammonia is always found in dense atmospheres full of hydrogen like gas giants. If there is a huge ocean, then we can expect less ammonia, because there is less atmosphere to produce it. That is why some researchers think that it is an ocean planet, and it is the one that best fits the observations. Before finishing analyzing all the complete data, I will tell you that some news websites and channels have been filled with headlines such as that there is life on K2-18b, that the planet is a super-Earth full of life, that the news is imminent, and that NASA is hiding information before being sure. Conspiracy theorists on the attack. In addition, it has been predicted that K2-18b is more suitable for living than Earth. It is true that a lot of information about this planet has been hidden, and you are going to know the great truth. First of all, this preliminary study is incomplete, and the following information has been hidden from the public. What kind of information? Very important scientific information that is not of interest. Physicists usually classify findings into 5 sigma levels. The 5 sigmas of statistical significance are only liked by some physicists who love real data and do not spread rumors. 1 being the least reliable and 5 the most reliable. A level of 1 is considered insignificant, and there is a 68% chance that it is false. On the contrary, a level of 5 corresponds to a reliability of 99.99%. Well, the discovery of dimethyl sulfide on the planet K2-18b is at a level of 1 sigma, meaning very weak evidence. To confirm this gas we need a level 5. This means that the detection is clear enough that it only arose from random fluctuations in the information that reaches us once in 50,000 times. This level 1 is very far from the level 3 of sigma that is used in astronomy to ensure a significant discovery, and even further from the level 5 that confirms it. This means that the discovery of dimethyl sulfide only corresponds to very vague indications and is pure speculation, and in no case can it be associated with indications of life or with an important discovery, although it is interesting. Detections of 1 of sigma appear all the time and most are false positives. And now you will tell me, why has this information been hidden and have rumors of life spread so quickly? And why is it said that NASA is hiding information? Simply because saying that there are very weak indications of dimethyl is not media-friendly. On many sensationalist websites and channels they don't like to tell the whole truth. It's much better for them to leave the unknown in the air, to say that NASA is hiding the information and to eliminate what is not interesting and to continue saying that we have discovered life and that the news is imminent. Another fact that is not entirely correct is that it is said that the planet is a super-Earth, but in reality, it is in an intermediate category between super-Earths and mini-Neptunes. It was already dismissed as a super-Earth when James Webb observed it, due to its low density. There are only 2 possibilities. Either it is a mini-Neptune or a planet with a high-pressure water ocean, since as I mentioned, it is at the limit of what is considered an oceanic world, that is, a world with a hydrogen atmosphere and an ocean. James Webb has already been able to observe 2 passes of the planet, and we have a new, almost definitive study of it. New study of K2-18b. It confirms what was suspected, at least some of us. This study has been led by Nicholas Wogan, of the Ames Research Center of NASA and the University of Washington. Climate models show that it is a mini-Neptune, full of hydrogen gas at high pressure. A planet that looks more like Uranus and Neptune than Earth, and therefore it cannot be habitable or have artificial lights of any kind. Another fact to keep in mind is that it has a hydrogen atmosphere, and this means that certain gases that on Earth are considered strong indicators of biological activity may not be so reliable. Although dimethyl sulfide could be a good biological marker, its detection in a hydrogen-rich atmosphere would require careful evaluation to rule out natural sources that could arise in chemical conditions different from those of the Earth. In the first place, a planet that has methane and carbon dioxide is not surprising, since there is some on Mars and Venus, even on Titan. And we have a long historical list of confirmations of life that have not been as such. Since the WOW signal, Oumuamua, the phosphine of Venus that turned out to be something else, the study of pulsars and along etc. So we have to be careful. A climate model of a cold planet with an uncontrolled greenhouse effect is being used, which is incompatible with an inhabited aquatic world. And as things stand, the balance clearly leans towards a gaseous world. We will need 2 more passes of the James Webb during the year 2025 to check if there is that ammonia that tells us if it is a gas giant, or on the contrary it is a lifeless ocean planet, which is the most likely, at least 70% from my point of view. Conclusion. The conclusion is that no signs of life have been detected on K2-18b, either now nor in the preliminary study. We only have evidence of a very weak signature of dimethyl sulfide, which even if it were confirmed, we need more studies of its hydrogen atmosphere. If it is from a biological source or not, then we could say that there are signs of life on that exoplanet, but whether there is life or not. On K2-18b, this discovery is very exciting, because we are discovering a type of planet that we never imagined. And they're on the road to the analysis of the atmospheres of other worlds. The discovery of life in the universe is something very serious, and many of us take it very seriously. The detection of life will not happen from one day to the next, nor will there be big news. It will be a study over time of the atmospheres to detect biosignatures, that is, gases produced by living beings. Once confirmed, we will need more analysis to deduce that it is indeed a biological process and not a natural one. Furthermore, neither Hubble nor James Webb are currently equipped to detect artificial lights directly on exoplanets. This task would require telescopes with extremely high resolution and unprecedented sensitivity. On this grand stage of the cosmos, there must be many worlds with life, especially microbial life. But discovering microbes hundreds and thousands of light years away will require extensive studies over years. Understanding atmospheric chemistries will require extraordinary evidence to confirm extraordinary claims. But don't be impatient, we've only just begun.
Hush.